So this is part 2 of exercise 5, day 2. Today you will learn how to use the ImageJ tutorial, and for that you will have to follow the instructions from the lab manual, and you can find more details on Blackboard. So under course documents you will find exercise 5 day 2 that will be available at 2 p.m. tomorrow. So you will click on it, and inside of that folder you will find gel image for ImageJ tutorial and band size standard curve slides. So for the slides you will see that the instruction will say to follow the appendix 2 in part B of the lab manual in page 97 on how to determine molecular weights, but I'm going to show you on the video as well. And the first things that you have to do is to download and install ImageJ. So if you Google ImageJ online, literally Google ImageJ, and then you will get to the NIH website. And then within this you will go to download, and then you will have to choose which is the computer that you're using. Be aware that if you have installed the ImageJ in the past, you most likely have to re-update it, because otherwise it will not work with the new Java that you have installed into your computer. For people with Mac, if you're installing it for the first time, the computer is gonna complain, and it's gonna tell you that it cannot install it because it's from an external web page, etc., etc. But then you have to go to System Preferences. This is a software that is safe to download. It's from the NIH, so it's pretty safe. And you will go here to Security and Privacy, and under General, now it's not display, but you will click and Open anyways, and you will click on that, and then you will be able to open ImageJ. So once you have it open, you will close this for a little bit. You will have something like this. So it will only open this tiny little bar here that it will say ImageJ, and then you will see it will be displayed differently on PC, but it's a similar idea. It's a really minimalistic software, but it's really useful. There is many other options, so today we're just using one of the simplest ones, but you can find more tutorials online, and it's a really free software that can help you a lot on your research. So we will open the file that you downloaded from the Blackboard. Let's show you again. Where is it? Sorry. Where is it? It's here on Blackboard. So you will download this gel image for ImageJ tutorial, and then you're gonna go make sure that you click in ImageJ and File, Open, and then you will open this one, and it's gonna open this realistic gel to be nice. So this is a gel that was produced a couple of semesters ago, and the nice thing about it is that you have a ruler here that you can use to calibrate the software. So the first thing that we're gonna do is to calibrate it, and for that you're gonna use your mouse, and you will click in this icon here that is a straight line. Boop. You click on there, and then we will click. This is really important when you do this type of measurements in any type of visualization software. You have to establish your own criteria for determining where where you're measuring the distance, because here we're gonna tell the software from where to where certain amount of pixels are equivalent to a certain distance in centimeters or millimeters or whatever unit you are using. So in this case, you will see that the lines are quite thick and they have a couple of pixels of white. So then I'm going to stick all the time measuring every line at the bottom of it. So I'm going to click first here and I'm going to drag it until the main line of 4, trying to make it as straight as possible. And then you see that I position the mouse at the very bottom of that line, and then I will release the mouse, and that's it. So then I'm gonna go to Analyze on the main menu, and then I'm gonna tell the software to set the scale. And on set the scale, it's gonna display this window. It's gonna tell you how many pixels the line that you just draw is equivalent to. But then we will tell the software that that distance that we measure is equivalent to 1 centimeter, and we're gonna change the known distance to 1 because that's what we measure, 1 centimeter here between 4 to 5, and then we will tell the unit because we know that is centimeters, so centimeters, and then we will click OK. So here you can make sure that the software is gonna know that every 320 pixels is gonna be equivalent to 1 centimeter. So we click OK, and now we are all set. It's calibrated. So now we're gonna use another feature, and we're gonna put it a little bit below here. So now the whole idea is that we will generate the data to do a standard curve. So for that, I'm going to explain you a little bit more with the PowerPoint again, so you can open your PowerPoint. So the whole point of having the ruler is that you can do this also directly, but with the software it's more sensitive. So the migration of the bands is in a logarithmic scale. So what we will do is to produce a standard curve based on the ladder, and for that we're going to measure the distance that each band migrated from the loading wells up to where they stop based on their base pairs, and we're going to measure the distance, so from here to here, from here to here, and so on, and that's going to give us a standard curve for which we're going to calculate the logarithm in base 10 for them. So we will use the ladder here that is nicely labeled here, the base pairs that they represent. So we always measure from the top, very top of the picture. We will assume that this is straight and that is evenly cut, so it will be the same distance that they migrated. So we will press the mouse click and draw the line up to the bottom of the first band. We're gonna release, and then we're gonna go again to Analyze and gonna click and Measure, and then it's gonna display this table here, and then you see the length, and this length, because we told already the software, is gonna be on centimeters. So that's the distance that this band migrated from the very top of the gel. So then we're gonna do the same for the second one, and then we know that is the 10,000. And again, Analyze, Measure. Do the same with the third, that is 7,000. Analyze, Measure. Now 5,000. Analyze, Measure. We have to do it as many you do, the best fit for the curve. Sorry, for the trend line that you're gonna obtain. Let's measure. And it's important to go all the way to the tiny ones because that is where you will see that it's actually a logarithmic scale. Oh, maybe I mess up here. Thousand. And then these ones are very, very blurry, but we're gonna try to do it anyways. So that's how important is that you get a nice image too. There. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 bands. Let's see how many we got it here. Great, I measured twice. I think it's this one here. So we're gonna erase that data because that's the one where I probably mess up. Sorry, this one is the one that I counted twice. So clear. There. So now we can just copy this. So we select and then Control or Command C on your keyboard, and we will go to Excel. And then we can copy it here. So I have this table pre-made. So we don't want these two first line. We just delete it. We're just gonna stick with the migrated distance in centimeters. So this is here, and then we go back to our gel to put the equivalent band size in base pair. So we know that that is 20,000, 10,000, 7,000, 5,000, 4,000. Really fun. But actually, it is useful in some cases. Usually, you just use the ladder by eye. You can, because you probably know what you're expecting, but in some other cases you have no clue, and this conceptually is really important for you to practice. So now we have the first data here. Oh, and I have a problem with my Excel just because it recognized that I speak Spanish, so it changed it likes the comma instead of the dot. So I'm just gonna replace I'm gonna replace, but you don't have to do that. Fine, replace dot by comma, replace all. That's just a problem I have because everywhere else that people use metrics, they use comma instead of the dot. Anyhow, so now we can ask the software to give us the logarithm base 10 of the band size, actually. So for that, we press equal, and then within the functions, we press log 10, and then we place our mouse in between the parentheses, and then click, boop, and then you just can drag it, boop, 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 and that's it. So now we will copy this, the distance migrated, paste it, and then we will do a special paste. So Control C, copy, and then right click to paste special. So we'll paste the values only, values. And now with these two columns, we can generate our graph from which we will obtain an equation. So, yoo-hoo. So now we have a line from which we can obtain a linear equation. I will just show you why it's more difficult to do it right directly from the raw data, for saying in some way. I will just show you. You don't have to do this, but it's a logarithmic, right? So then it's way more difficult to calculate back the equivalent data. So that's why we are using logarithm in base 10. So now you have done this before. You select the whole data set. You do right click, add trend line, and then it's a linear, it's fine, and then equation on the graph. So that equation is the one that we will use. So here you have to put attention. Excel for some reason doesn't like to label. You can ask data. Let's add the axis. So then you see that in here, in here, this is the distance migrated, right? So the distance migrated in centimeters, and our y-axis is the log base 10 of band size. Okay, so now we have the formula, and if you use it correctly, you want to solve for x. Sorry, let me see one thing here. Yes, that's correct. Okay, so what is the information that you have? For example, if we go back to our gel and we want to know what is the size of this band, we do the same tool. We click at the very top and we go to the very bottom, and then analyze and measure. Oops. And it should show us this distance. So the distance that migrated was 2.64. I'm gonna write it down here. Okay. So then we know that we can solve for that. So we will use the formula and replace the value of x there. So it's gonna be equal minus 0.5846 times x, that is our migrated distance, to 64 plus 47835. So it gave us the equivalent for the y-axis. So it said 3.2 for blah blah blah. So then to solve for that, we should do the antilog to know the band size equivalent. So by definition, to find the logarithm, the antilog, you have to find the number for which the logarithm that you obtain, it will give you the x. So we will put 10, and then that symbol you can copy. So it's called caret. I don't know how to call it from the Excel itself. So just Google caret and copy the symbol. Put it there, and then we write our logarithm base 10 3.240156. So it told us that is about 1,700 base pairs. So let's see if that makes sense. Hopefully it does. Where is it? And yes, it does actually, because it's right in between the 1.5 and then the 2,000, and that makes sense. So that's how you find more precisely the size of your bands, and with a better, if your image is better and more sharp images, it will give you more accurate results. But this is the general idea of how to solve it. Please let me know if you have any questions. We can make an appointment one-to-one. We can do a Skype meeting, and whatever it works better during this time, on which we still don't know what is going to be the final policy that the university adopts facing the COVID-19. Okay, I hope that it helps you, and have fun doing it. Bye.